Hi, the curve C has equation y is equal to x squared plus 3 over x squared plus 1, and we need to show that C has no vertical asymptotes and state the equation of the horizontal asymptote. Now, when we look at the denominator over here, we understand that x squared plus 1 cannot equal to 0. So then that shows it has, therefore, no vertical asymptote. And for the horizontal asymptote, we have y is equal to x squared plus 3 over x squared plus 1, leading to y is equal to 1. So that's the horizontal asymptote. As for the second part of the question, we need to show that 1 is less than y less or equal to 3. So if y is equal to x squared plus 3 over x squared plus 1, then we can actually rearrange this where we have x squared plus 1 into y is equal to x squared plus 3. And rearranging this, it leads to yx squared plus y is equal to x squared plus 3. So grouping all the x squared together, and we've got the y over here, and then minus 3, all of that should be equal to 0. So simplifying further, I've got y minus 1 into x squared plus y minus 3. So this is the quadratic equation where we can actually solve for x. But then again, when we look at this, we know that the value of a is y minus 1, the value of b is 0, and the value of c is equal to y is equal to, c is equal to y minus 3. So we can use b squared minus 4ac less than 0 to give us the values of y that cannot be obtained. So then we have 0 to the square minus 4 times a is y minus 1 times c, which is y minus 3, and that should then be less than 0 as over here. So let's try and solve this. So solving, we get y minus 1, it's an inequality over here, 3 and less than, so that's going to become greater than 0 divided by minus 4. So the critical values are y is equal to 1 and y is equal to 3. So these are my critical values. So now if this is greater than 0, what we're saying is that y is then supposedly greater than 0, greater than 3. And over here I've got y minus 1, so then y should be less than 1, basically, because the critical value is 1, so it's less than 1. So these are the values of y that cannot be obtained. So by contradiction now, we can say that so if y is less than 1, so then y is greater than 1. So this is what can be obtained, but y cannot equal to 1. So we're going to come and discuss that in just a moment. If it's greater than 3, then the opposite would be less or equal to 3. So we're saying then 1 is less than y less or equal to 3. The reason y cannot equal to 1 is because if I substitute 1 into this equation here, x squared plus 3 over x squared plus 1, we end up with 1 not equal to, this is x squared, okay, plus 1 is equal to x squared plus 3, and we understand why 1 cannot equal to 3. So that is why it cannot equal to 1. So here is the set of values of y, okay, that we need for this equation. So find the coordinates of any stationary points on C. That's the third part to the question, part C of the question here. So remember, we have y is equal to x squared plus 3 divided by x squared plus 1. So we're going to be using differentiation here, quotient rule. So we're going to have to find dy by dx and set dy by dx to 0. If we do so, then dy by dx is going to be equal to v du by dx, so x plus 1 into d by dx times 2x, okay, minus u dv by dx, and u is x squared plus 3, then d by dx is 2x, we can see the 2x is common, but then again divided by v to the square, so that's x squared plus 1 to the square, and all of that should be equal to 0. Now we're going to simplify this, and so it leads to all of that equation over here, and we get x is equal to 0. We're going to substitute that into the original equation itself, leading to y is equal to 3, and hence the stationary point is 0, 3. So here we are for the part C of the question. Now part D, we need to sketch the coordinates of any, sketch C and stating the coordinates of any intersections with the axes and labeling the asymptotes. Right, so we're going to try and draw this now. Now remember, we have the horizontal asymptotes, y is equal to 1. There's no vertical asymptotes, and we have 0, 3 as the maximum point of the curve, and so we can draw the sketch the curve C rather. So given the software that I have, this is the maximum, this is the best I can do with this curve. I understand that this would be the maximum point, and here's the line y is equal to 1, which is the horizontal asymptote, and so that's it. So this is how the curves can look like if you sketch it. Okay, so now moving on to part E of the question. So we need to sketch the curve of y is equal to x squared plus 1 over x squared plus 3 and find the set of values of x for which all of that's going to be equal to less than half. So let me just try and find out now when x is equal to 0, so we have y is equal to 1/3. And right, so let us see now. And because this 3 is down, because originally the curve was like x squared plus 3 divided by x squared divided by x squared plus 1. So now it's the inverse of this, and it's a reciprocal of this. So when x is equal to 0, I have a coordinate y is equal to 1/3, and the next thing that I need is the horizontal asymptote. So the horizontal asymptote is still the same, because the degree of the numerator is the same as the degree of the denominator, so we've got y is equal to 1. So now a curve is going to look something like this is the line, and it's going to look something like this. Alright, so because now this is what we are going to sketch in just a second. Alright, so let me just try my best here. So this is what I get for the sketching of the curve with all the points and markings. Now I need to find the set of values of x for which this inequality here is less than half. So basically what we're going to do, we're just going to solve x squared plus 1 over 3. So x squared plus 1, over x squared plus 3 is less than half. So this is not that difficult to solve, so we can just do that. And so we cross multiply here. I got 2 into x squared plus 1 being less than 1 into x squared plus 3. So then 2x squared plus 2 being less than x squared plus 3. So 2x squared minus x squared on both sides, I'm going to get x squared. Okay, and if I were to minus 3 on both sides, it's going to turn into minus 1 less than 0. So x minus 1 and x plus 1 is less than 0. Difference of two squares. So we have then 1 and negative 1, and so we're looking at less over here. So less means right, so what we have is less than 0, so it's going to be all over here. So then I have minus 1 to 1, so minus 1 being less than x less than 1. So here we are. This is the part E of the question, and we're done for question number 6. Take care.